Welcome, everyone. Today we will explore Miller's information processing theory and its relevance to learning and instructional design. I am Robert Bogle, working with my partner, Melissa Henderson. We will be discussing the creator of this theory, psychologist George Miller, give an overview on the information processing theory, and finally discuss memory capacity, chunking, and its implication in cognitive psychology and education, giving practical application, examples, and references for future research. Born February 3rd, 1920, George A. Miller was a pioneer psychologist who helped transition psychology from behaviorism to cognitive science. His work on short-term memory and chunking has been highly influential in education, artificial intelligence, and human-computer interaction. While doing research at MIT, he found that behaviorism was too limited, making an argument that cognitive theory was a legitimate subject of research and could be observed through objective and empirical means. Miller proposed a law of human cognition and information processing that humans can only effectively process 7 units or chunks of information at any given time. Miller did not stop there with his achievements in research. He went on to develop WorldNet.com, an online English word database that helps simulate human verbal organizational memory, as well as co-found the Harvard Center for Cognitive Studies and the Princeton Cognitive Science Laboratory. He has written several books of his theory and received numerous awards and honors for his work. He is considered one of the most important psychologists of cognitive research, and he's listed as number 20 of APA's list of 100 most eminent psychologists of the 20th century. Miller's famous paper, The Magical Number 7, plus or minus 2, highlighted the limits of short-term memory, leading to the idea of organizing information into fewer units or chunks, with 7 plus or minus 2 bits of information per unit. His belief increased the type of data that the brain can process and helps the brain overcome 7-unit limit on processing information. Miller tested out his idea by initiating a hypothesized behavioral sequence called the TOTE, which is test, operate, test, exit, where a goal is placed, then tested, and if not achieved, operations must occur to achieve the goal. Then tested again, only to exit the sequence if the goal is achieved. If it is not, then the process must repeat until the desired goal is met. This sequence serves as a basis of many problem-solving theories we use today, thus giving us the information processing theory, which examines how we take in, store, and retrieve information. It explains why learning strategies work better than others, and the limit of the human brain when given a set of number of stimuli. His theory, behavioral sequence, as well as strategies continue to help educators and designers structure information in a way that optimizes retention and recall in the classroom as well as in the instructional design space. Part of the information processing theory teaches us to employ the chunking techniques when presenting information to learners. The importance of chunking allows learners to process and remember information more efficiently. The average human brain employs chunking every day to remember important codes and information. And as instructional designers, we can incorporate chunking to enhance learning for development in learners for long-term memory. So take this as an example. Remembering a 10-digit phone number is a lot easier when you split it into segments rather than trying to recall all 10 digits separately. This is why phone numbers and other sequential data are often grouped into smaller chunks for easier recall. Next, we must look at how we can move what we've chunked from short-term memory to long-term memory. To move information into long-term memory, it needs to be encoded properly in the brain. A key to this would be repetition. For instance, when the learner repeats presented chunked information in either a written or verbal format, they will be able to make connections into existing knowledge. where the learner can mentally connect repeated chunked material to what they already know. Then they finally actively engage in what they have learned using practical applications to get hands-on experience with the required material. It is now encoded in the brain as long-term memory. An example of how this is done is studying for an exam. The learner will take notes on the presented material that has been previously chunked from the instructor. Reread or listen to the notes. Then make connections to activate prior knowledge and finally engage in the exam. When designing instructional materials, minimizing cognitive load is crucial to enhance learning effectiveness. Cognitive load refers to the amount of mental effort required to process and retain new information. If learners are presented with too much information at once, their working memory can become overwhelmed, leading to frustration and decreased comprehension. To combat cognitive overload, instructional designers can implement 3 strategies. Scaffolding. This technique involves gradually increasing the complexity of materials, allowing learners to build knowledge step by step. As an example, in mathematics, a teacher may first introduce basic multiplication before progressing to multi-digit multiplication or word problems. Chunking. As stated before, chunking is breaking information into smaller, meaningful parts that helps learners process and retain content more efficiently. As an example, a history lesson might be divided into major time periods or themes, making it easier to digest. And mnemonics. Using memory aids such as acronyms, rhymes, or visual associations can reinforce retention. For example, the acronym HOMES helps students remember the Great Lakes: Huron, Ontario, Michigan, Erie, and Superior. Mnemonics are especially helpful for subjects that require memorization, such as science terminology, language learning, or medical education. By integrating scaffolding, chunking, and mnemonics into instructional design, educators and trainers can create more effective, engaging, and sustainable learning experiences. The goal is to reduce unnecessary cognitive burden, allowing learners to focus on the understanding of concepts rather than struggling to manage excessive information. The principles of cognitive load management extend far beyond the classroom. In education, teachers use chunking and sequencing to structure lessons, ensuring students are not overwhelmed with too much information all at once. This is especially useful in subjects like math and language learning, where complex concepts must be built progressively. In user experience or user interface design, simplicity is key. Designers create interfaces that reduce cognitive overload by organizing content logically, using clear navigation, and limiting the number of choices on a screen. Think about how an intuitive website or an app helps users find what they need without frustration. Additionally, memory aids like mnemonics, stories, and patterns are used across disciplines to improve recall. For example, medical students use mnemonics to remember anatomical structures. Marketers rely on catchy slogans to enhance brand recognition. By applying these strategies, we improve learning efficiently and the user's experience in various domains. Miller's theory provided an essential foundation for understanding short-term memory, but modern cognitive psychology has built upon and refined these ideas. One major critique is that memory capacity is not fixed. It varies between individuals based on factors like age, expertise, and prior knowledge. Furthermore, some researchers argue that working memory is more complex than simple number limits. Baddeley's working memory model, for example, introduced the idea of multiple subsystems, such as phonological loop for verbal information, the visuospatial sketchpad for image and spatial data, and the central executive, which manages attention and task coordination. In real-world application, memory limitations depend on task complexity. For instance, we might remember a short grocery list but struggle to recall detailed scientific concepts without additional reinforcement. As research evolves, educators and designers can use these modern perspectives to tailor learning experiences that accommodate individual differences in cognitive processing. To summarize, memory capacity is limited, but we can enhance learning and retention by structuring information effectively. Chunking and organization help break down complex ideas into manageable parts, making them easier to process and remember. Instructional design plays a crucial role in reducing cognitive overload, ensuring that learners can engage with material without feeling overwhelmed. Understanding these principles allow professionals in education, business, and technology to create more effective learning environments, training programs, and digital interfaces. By integrating these strategies, we maximize cognitive efficiency, leading to deeper comprehension, improved retention, and a better overall learning experience. Our references that we used: we thank you for your participation.